That wasn't happening before. Now it is. Oh. All right. Cool. Okay. So gone through and took ran analyses with this. And so always, when you go through and run these types of models, once you got your omnibus effects, actually before you've got your omnibus effects, hopefully you have a game plan for pulling apart these analyses before you start, right? But always before, you don't want to just start jumping and mucking around doing stuff. You want to have a game plan, right? So here for this problem, our game plan, we're going to determine the magnitude of pre-post treatment reductions in depression, right? I'm not interested in whether or not there's a significant difference because it's massive, right? The test is superfluous, but what I want to know from a research standpoint, from a clinical standpoint, like if people come into this project, into this program, how much of a change should I expect them to sort of to demonstrate on this outcome? And what are my data supported values? What's the magnitude of the effect? That's really the most important piece of things, absent some need to determine whether or not how much of a change is there from baseline to 2 weeks or 3 weeks to 4 weeks or something along those lines, right? So there's lots of things we could look at. I'm choosing not to. I'm saying this is the stuff that's most important, that carries the most impact. So we're going to do that. So then here we have a write-up, right? Talking about follow-up analyses indicated an average reduction of 17.8 points with population estimates ranging 16.5 to 19.1. Responses exceeded conventional benchmarks for large effects patients, demonstrating nearly 1.6 standard deviation change in scores. Lower bound estimate is still consistent with massive effects. Results offer substantial support for large and clinically significant change in global depression in individuals receiving inpatient care. How do we like that in terms of an interpretation of what we've got? It's all right, right? We kind of get important pieces of information in there that's relevant, right? Or we could do this, right? Follow-up tests indicated significant reductions in overall oppression. Is that cool? No, that sucks, right? Wanting to go through and think about like, what's the information that we can go through and pull from these that's actually meaningful, that conveys information that's going to be useful for other people, right? Sort of falling back on yes, no decisions is boring and not incredibly useful. So wanting to think about what's happening, how do I communicate stuff that's interesting and helpful? And a lot of times that involves sort of talking about effect sizes, talking about confidence bounds, and particularly for stuff like this, like what can I tell the next person about what the likely effects they're going to get if they were to sort of go through and replicate this stuff, okay? All right, so, all right, what I'm going to do here is pull up our other data set. So this is our beliefs data set, our unordered means. Pull up right now, so your one-way repeated measure ANOVA for your one-way stuff. Okay. So just as a reminder, what we did here. Okay. So here we're going to go through, we're going to go general linear model, repeated measures. Call this vignette. Here I have 8 of these things. Yeah. Add, fine. And here, remember what we're doing is we're giving people vignettes that involve trauma and non-trauma related types of stuff and saying, hey, would you still be friends with this person? Continue, and I'm going to go to plots. Yet. horizontal axis, add. Okay. We're just going to go through and run this general model here. So remember that once again, we have very clear evidence for differences across our repeated assessments. And remember, this is in this study, what we did is we had 8 different vignettes and we just kind of counterbalanced them, administered them to folks and had them rate. So like, yeah, I would be willing to maintain friendship with sort of hypothetical individual who's been exposed to whatever. And if we look at, remember, our descriptive statistics on this, what did we see, Matt, in terms of the mean values and our descriptive statistics across willingness to provide friendship across each one of these vignettes?
All relatively similar.
Yeah, they're all relatively similar, right? I mean, we're kind of asking people a loaded question, be like, hey, are you a reasonable human in this hypothetical vignette that costs you nothing to sort of just hit the top of the point, right? But despite seeing responses that were very, very similar, what did we find when we looked down at our tested within subjects effects here?
Oh, sorry.
Yeah.
I didn't know you were asking me.
Yeah, I'm sorry.
It's cool. So we did find evidence that there is differences.
Yeah.
Different vignettes.
Right. Our test of our repeated measure just says that, yep, there are differences across repeated assessments of friendship ratings across this, right? Now, do we know where those are? No, right? And this starts to become a little trickier because the order of this is all completely arbitrary, right? Now, Amanda, if we're going down through and taking a look, we still get, SPSS will still give me a test of within subjects contrasts. And I've got, boy, a 7th order polynomial that is very, my 6th order polynomial has a partial eta squared of 0.205. Should I be excited about that? Yeah. Yeah. Am I excited about that? Is there any reasonable pattern to these? No, right? This is an example. We got lots of really, really tiny p-values and really impressive partial eta squared. But remember that 6th order polynomial is just a line that has like 5 bumps in it. But it goes from infinity, 1, 2, 3, 4, 5, and then back up, right? There's nothing informative about that. Right now, if we go down through and take a look, just the way I happen to have loaded those means in, I get kind of sort of this pattern, right? But is there any reason that these vignettes needed to be loaded in this order? No, right? And so again, one of these things that always important, sometimes we can kind of fixate on small p-values and get really excited about stuff, but we want to make sure that we know what it's sort of talking about. Here, there's no natural order to this. So there's no reason to even look at that trend analysis because it contains no meaning, okay? If I were to go through and rearrange the order in which I entered these into the analyses, I would get a completely different result, right? So we don't worry about that at all, okay? But if I do go down through and I take a look at my means, what's that? Yeah.
Sorry.
Yeah.
I remember in the past we had done it where you were looking at correlation, that it was kind of good. It's like, wow, this variable is.
Sure.
So I guess what is this telling us?
Well, basically, this would say that a 6th order polynomial would account for 20.5% of the total variability in the means across.
So it's saying like 6 of these.
No, it's saying that the pattern of means that I'm seeing
Okay.
follows a 6th order polynomial, right? I'm really excited. I get to talk about 6-order polynomials. Right? So you got 1, that's a cubic, 4, 5, 6, something like that, right? It's saying that this function accounts for 20% of the variability that I saw in these means.
I understand that that's not really going to tell us much of anything.
Yeah, yeah.
Order.
Yeah.
So, okay.
So, and that's why. And so Elizabeth, I went through and were to reorder all the highest ones together and then all the lowest ones together, then this sort of polynomial doesn't fit anymore.
20% is just strictly saying based on the way that we have it, like line.
Yeah. Yeah.
Okay, so now.
Yeah. Yeah. But it's just a made up thing. It's not, it's like just a cryptocurrency. It's not real. It's just, it only has value given the way that I've gone through and set these means up. If I were to switch them around, it would be a completely different thing. And I could sort of arrange these in a way that did, but unless there's some sort of conceptual meaning for these things, then it's functionally uninterpretable, right? But a different thing than like with the previous example where we have treatment where people start in 3-dimensional universe. I start here and I move forward in time. I can't go back. Now all of a sudden it has a meaning where this is beneficial. Yeah, yeah. And so this is the difference between ordered, unordered types of means, right? A lot of times our repeated assessments are set up so that it's following some sort of thing. And then in that case, it can be useful, but in here where it's completely arbitrary, this is just an experimental study, right? I could and did rearrange these. There's no actual order. There's like 15 or 20 different orders that I gave people these in. And so there's nothing inherently meaningful about the position of these, which renders that trend analysis uninterpretable. Yeah. Did that get it? Okay, cool. All right, other questions? All right, so the one thing we need to do, but we do need to go through and figure out exactly what we're going to do with this, right? Because I've got a lot of different means, but remember conceptually, I've got the first 4 vignettes had to do with trauma-focused stuff, and the last 4 vignettes had nothing to do with sort of general stressors. So here, if I look up, what order did I put these in? So we've got car accident, combat, assault, sexual assault, disaster, partner infidelity, chronic illness, relocation, lost all my money, right? So we've got here some differences that might play into what I want to look at in terms of how I might approach this, okay? So if I go through, actually, do is, okay, we'll do that. I didn't. Okay, yeah, so you people can follow along. Okay, so what I'm going to do is I'm going to say, like, of this whole design, what I want to do is I want to test and combine what I'm really interested in, and I knew this before I even ran the analyses, was I was wanting to know, are people more willing to provide support to survivors of clinical trauma than people who are exposed to just general stuff, okay? And so in my thinking about this, I wanted to say, hey, I don't want to just have like, oh, trauma. I want to back, what I want to do is get like ratings for specific types of trauma and specific types of other types of stressors and really take a look. But what I'm really interested in this design is whether or not I'm seeing a difference in terms of willingness to support serious clinical trauma versus sort of other types of stressors. So I went through, created 8 different vignettes, 4 of which are actual clinical trauma, 4 of which are non-trauma. But my real test is do people provide less support for big T trauma than other stressors. Okay. So how do I set this up in terms of a comparison? What can I use? Yeah.
Like the weighted.
Yep. This is going to be my contrast, right? I could look at 1 versus 4, 1 versus 5, 1 versus 6, 1 versus 7, 1 versus 8, 2 versus 4, 2, like, then I get like, that's going to be a complete mess, right? What I want to do is I'm going to set up a contrast to say, based on the means that I'm seeing, do we see the combination of these be different than the combination of these? Okay. And so what I'm going to do then is go through and I'm going to set up my, and I'm going to set up my contrast. Okay. Here I've got the value of my contrast is I've got 4 trauma vignettes and 4 non-trauma vignettes. So what are my weights going to be? Yeah. Yep, exactly, right? And so I can write this out as negative times mean 1 plus or minus 1/4 times mean 2, and so on and so forth, plus 1/4 times mean 5, plus 1/4 times mean 6, right? If I was going to put it out longhand, like that's what it would look like. Here I've just kind of condensed it down. So I've got negative 0.25 times 7.654 plus 7.338 plus 7.654 plus 7.636, right? This is capturing my trauma ratings, right? Plus 0.25 times the means of my non-trauma stuff. Okay, this is a mistake. That should be 7, not 3, but okay. So go through, get the value of my contrast, right? Now, notice that in my hypotheses, what I was hypothesizing that was that people would provide less support to my trauma survivors than my non-trauma survivors. So because of that, I weighted my trauma weights as negative, my non-trauma is positive, okay? When I go through and actually calculate the value of my contrast, I get a value of negative 0.256. What does that tell me?
Difference between the sets of means.
It's the difference between the sets of means, exactly. So I'm saying that there's about 1/4 of a point difference between the combination of my trauma means versus the friendship means versus the combination of my non-trauma friendship means, right? But what does that negative tell me, Matt, with the way I've set it up?
The first group to have more of the quality.
Yeah.
Second group has it. So
yeah.
The second group is experiencing more trauma.
Second group is sort of friendship ratings for the second group are higher than the other. So this is telling me all of a sudden, with the way I've set up, that am I got evidence for my hypotheses or the opposite direction? The opposite direction. Now the sign is completely arbitrary, right? But if I go through and I set it up to be consistent with sort of my hypotheses, it's going to make it easier so I don't have to sort of accidentally say, oh yeah, I have a big effect, but in the opposite direction, but don't recognize it's in the opposite direction. So being careful there. Yeah. So the average rating for willingness to provide friendship for the trauma scenarios, the trauma vignettes, was about 7.6. And the average willingness to maintain friendship with the non-trauma scenarios was about 7.3. So we're actually seeing the opposite of what we had. But 1/4 of a point on a 0 to 8 scale is not that much, right? So who knows if I've gone through and found anything here, right? So I'm going to go through using the formula for the within subjects contrast that we presented here. I've got negative 0.256 times, we've got 1/4 squared times 4, just because I have 4 1/4 weights, plus negative 1/4 squared times 4. That's just giving me all of my weights. That's accounting for all 8 of my weights, times 0.766. This is going to be, if you go back through and take a look at your output, where am I getting 0.766? Remember, this is my mean squared error. Yeah. Yeah. If I go through and I look at my tested within subjects effects, my ANOVA table, that's my repeated measure. Remember that when we take these, we take all the data, all the variability in the data, and we pull off the individual difference stuff, the between subjects, and set that over, and we're not interested in that. Then we take the within subjects, pull that over, and we go through and we look at sort of within subject stuff that's due to our effect, systematic differences, and error within. And so if I go through and I look at there, I'm going to go through because I'm interpreting the greenhouse geyser. So I'm going to pull my mean squared error from my greenhouse geyser rating there, which is 0.766. I'm going to plug it into my t-test divided by the number of people in my sample, which is 231. If I go through and run that out, it's going to give me a test statistic of negative 6.244 with degrees of freedom 1177. Where did I get that? Yeah. 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 Right. So it's the same as using the degrees of freedom for my overall ANOVA table. Now I've got a really massive set here, right? And if I were just looking at differences from one vignette to the other vignette, I've got 231 people. That would give me a degrees of freedom of 230 for just a paired sample t-test if that's all I was running in this. But 1177 is a lot bigger than 230, right? Which means that basically, I mean, sort of I've minimized sort of my criterion here, sort of based on the size of the sample. Yeah. Remember that who could tell me why do we go with the greenhouse geyser correction with this, or why do we need the greenhouse geyser correction for this?
Violated sphericity.
Because we have a violation of sphericity, right? Remember that the difference in ratings across all possible pairs of vignettes don't have equal variance, and so we've got a violation of sphericity, and so what we need to do is apply a correction, and our greenhouse geyser is just kind of standard in the field of sort of our correction for that. Okay.
So just like you could have used the non-developed or the lower bound.
No, it's your greenhouse geyser is going to be your most conservative of those ones there, and it's just going to be the one that people go through and use. Okay. All right. Cool. All right. So we go through, get a test statistic. I got a t-test of 6.2. Is that big? Yeah, that's massive, right? That's huge. If I go through and I actually plug a t-value of 6.244 with 1,177 degrees of freedom into my p-value calculator, I'll get this, right? I actually had to dump that into Excel because your p-value calculator online will just say less than 0.001. But if you dump that into one of your Excel calculators where you've actually calculated p-values for t-tests, I get a p-value of 5.94 times 10 to the negative 10th. That's infinitely small, right? I get an S value of 31, a Bayes factor of 2.91 times 10 to the 7th, right? What's our strength of evidence that there is, in fact, a difference between willingness to provide support for non-trauma versus trauma, or a difference based on the data we've collected? Through the roof. Functionally, these data couldn't exist if there was no difference in the population, okay? But the thing is, if we go through and take a look at our effect size, we go through and calculate here what we've got. What does this look like here? Oh, okay, this is just the average, right? So we didn't, basically kind of like a pooling thing, but basically I took the standard deviation of each one of these ratings and squared it to get the variance, then divided it by 8, and then took the square root of that to get the square root of my standardizer, right? This is just the square root of the average variances of all vignettes, right? Plug that in. I got the value of my contrast, negative 2.56, divided by the standard deviation of the average variances, drawn from the average variances of all this stuff, gives me an effect size of 0.24. So someone give me an interpretation of that effect size. Yeah. Yeah, it is small. It's on the small side. It's small, right? Yeah. So it's small, but basically we have massive evidence for a difference here. What's going on with this?
Yes, there is a difference.
Well, I wouldn't say virgin. Like, sort of, it's just small, right? Like we definitely do. Based on the evidence here, we have very clear evidence for a difference, and sort of difference in what direction, Emily?
Well, in our case, negative, like the big T trauma has less.
Other way, more, right? Our hypothesis was that people would be less willing to provide support for people with big T trauma. We actually found the opposite direction, right? So actually, what we found is, at least based on the vignettes, based on the data that we've collected in this scenario that we've set up, it's not a real scenario, but the scenario we've set up, we found that people are about a quarter of a standard deviation more, average ratings of willingness to maintain friendship are about a quarter of a standard deviation larger for people who are vignettes corresponding to combat, sexual assault, disaster, car accidents versus infidelity, financial loss, chronic illness, sort of this other stuff, right? So basically it's the opposite of what we'd expected. And we have very, very clear evidence, very, very strong evidence that yes, there is a difference, that people are differentiating these as different types of things, but it's a pretty small effect, right? It's about a quarter of a standard deviation. Yeah.
With these types of measures, do you think need to be directional? Like, do you need to say that?
Oh yeah, because otherwise, otherwise you're just saying there's a difference out there,
Okay.
but that's not informative, right? Yeah. I mean, what we want to do is sort of take a look at sort of the direction of our effects, compare it with what we had predicted, and then kind of go from there. Okay. Yes. Did you have a question, Elizabeth?
It was just related to that, like 2 times that small, but we know we have a difference.
Maybe. Yeah. No. I like where your head's at with that, because is this a meaningful difference? I don't know, right? It's a small effect, right? And so based on Cohen's initial conceptualization, it might not be something that we notice sort of a whole lot, right? But from a theory-based standpoint, it might be sort of kind of interesting, relevant, sort of what's the practical impact? I don't know, because what we've done is we've set up a completely arbitrary situation where we've said, hey, Elizabeth, here's someone who's had this, who's had this, who's had this. How willing would you be to provide support, maintain support and friendship for that person? The super arbitrary, or not arbitrary, but it's a derived sort of thing. To what extent would this correspond to like actual real life? I don't know, right? But if I'm thinking about this, the cost of you saying, yeah, sure, at the highest level is minimal. And the fact that even though we have some people still denying it to some extent suggests that maybe there's if anything, I would say that maybe this is just based on the methodology. I would sort of think that this is maybe an underestimate of the discrepancy, because I basically put someone in a situation to basically volunteer to say, no, if something bad happens to people around me, I'm not willing to maintain friendship. We're kind of swimming up. So the fact that we found anything is pretty amazing, right? So again, this is kind of taking into account. So is this a meaningful effect? I don't know. But it's at least interesting, I would say, the fact that anything came up at all. Would we have found this with just a straight up between subjects effect? Probably not. Like, it's too subtle, right? But again, utilizing our repeated measure design, we were able to go through and find stuff. Okay. So do people see sort of completely different study, completely different scenario, and kind of completely different approach to kind of tease apart what we found in these data? Now, there are lots of other reasons, ways in which these means can be different, but this is the one that's of most interest to me based on how I've set things up. Other people could look at it differently, but this is the way a test that goes through and addresses specifically what I want to address. Okay. Questions about this? All right. So if we go through and take a look here, we've got more of a kind of an involved interpretation that's pulling together what we found, kind of explaining upper and lower bounds for different pieces and parts and stuff like that. But again, just an example of trying to take all the information that we've got to pull it together into some sort of reasonable, informative interpretation that says something aside from, yep, these are different at p less than 0.05. Okay. So with these more complex analyses, there's kind of more stuff going on, more things to consider. But the good news is it's just basically an extension of the stuff that we've already talked about before. If you got t-tests down, this is all kind of, and sort of ANOVA stuff down, this is just kind of an extension of that. You just want to be very careful in thinking about, okay, what did we see? What are the implications? How do I knit this all together? Okay. Questions? All right. Cool. Okay. So we talked about between, by, within, and all this type of business. So what we've done up to this point is we've focused specifically on our one-way repeated measures ANOVA. This is a situation where we have one sample of people, and we've just gone through and collected multiple assessments from those individuals, generally sort of over time, right? Which can be interesting to say, hey, if I ask someone to do something again and again and again under different circumstances, do we see changes and stuff? Okay. But what we can do to start make this really interesting is start to look in and see, does a pattern of within subjects means change depending on some other individual difference factor, some grouping factor, something that we've measured and modeled. This is where we get into our mixed factorial designs. Okay. With our mixed factorial designs, what we've got is we've got a between subjects, at least one between subjects factor, and at least one within subjects factor. Okay. The most simple case would be like a 2 by 2 repeated measure ANOVA with repeated mixed factors ANOVA with repeated measures on the last factor, which would be, I've got two groups measured across 2 assessments. Pretty straightforward. Yeah.
Is it always the last factor, the repeated measures factor?
Generally, just by convention. You know, another thing too, when you're talking about these, I would very much encourage you to write this out. I'm going to say, like, this is a group, you know, or say call this a 3 group by 4 assessment mix factor, so on like that, just so people are very clear on how you've sort of structured this. I can tell you from reviewing papers, when people don't do this, it's a nightmare to try and figure out what they've got as their repeated measure, what's their between, what's going on, and then you can get into, so you can have multiple repeated measures, multiple repeated measures factors and things like that. It gets, these, as complicated as this seems, these can get very much more complicated as we start layering in additional between subjects factors and within subjects factors. So, yeah, this is convention, but just wanted to make sure that you were communicating very clearly where your different factors are and how you. It doesn't have to be on the last one, but you can do it that way. Yeah, yeah.
We were talking about like two groups. Why we're talking about like, maybe measured versus like.
Yeah, and so that's another thing too, is we got measure versus manipulated factor and group. So Bakeman is getting into, are you talking about, is your grouping factor an individual difference thing? Are we talking about men, women? Or are we talking about a condition that you've manipulated? Because those have different implications in terms of how they're framing, structuring error stuff, right? And it starts to make a difference. So if Lasha's running a study where she's looking at between subjects factors for some experimental manipulation, and then has that crossed with biological sex, so male, female. We got one thing that's a pre-existing factor. We got one thing that's a manipulated factor. They're both between subjects, but making the treatment. So if we're thinking about, as we start to add this in, where do we go through and partition variance out? I put together a handout of talking about a summary of repeated measures, sums of squares, and how things are panning out here. If I've got an A by B repeated measures ANOVA, right? Again, we've got some different questions we're asking. First, we're saying, if we're saying, if A is our between subject factor and B is our repeated measures here. Our first question is asking, do scores differ across levels of factor A, collapsing across repeated assessments? So if I say I've got, in this example, I've got 4 repeated assessments. If I collapse and just take the average across those repeated assessments, am I seeing differences across measures? Essentially, what does that question break down to? Go for it. Okay, so, yeah, and we're kind of trying to tease some of this stuff apart, but if I say, for this first question, do scores across levels of factor A, do scores differ across levels of factor A, collapsing across repeated assessments? What is that question essentially asking? What analyses is that sort of essentially setting up?
Just like an ANOVA, is there differences between the groups?
It's just a one-way ANOVA, right? And in this, just to orient you to the figure that I have here, we've got 1, 2, 3, 4 repeated measures. We've got 1, 2, 3 groups, right? And so here we have 4, and we're saying here we've just got 3 people in each group. Here's the average score for person across all 4, the first person in group 1 across all 4 assessments, the average score across all 4 assessments for the second person in group 1, third person in group 1. Here's first group person in group 2, second person in group 2, third group person in group 2, first and 3, second and 3, third and 3, right? These are collapsing across these repeated assessments. These are the means, right? And so my first question is, do I see differences in levels of factor A collapsing across repeated measures? It just breaks, it's functionally asking the same question as a one-way ANOVA model, okay? And Amanda, what are the mean in this table? What are the means that we would be, what are the means that we're being compared for that first question? Uh-huh. Yeah, which one? So which one is it? Can you tell me what the first mean is? Okay. Not, yeah, right here, right? This, right? If I take the average, collapse, if I take the average score collapsing across repeated measures for the group, is this different than this, different than this, right? It's just our one-way ANOVA, right? We're just collapsing and saying the average across our repeated measures. This first question, do scores differ across levels of A, collapsing across repeated assessments? It's just saying, does the grand mean for group 1 different than the grand mean for group 2? Does the grand mean differ from group 3? That's a between subjects question, okay? And so that's one question that should we get out of that. We also can ask, do scores vary across repeated assessment of factor B collapsing across group? Okay. Katie, where are we going to see this?
Give me a second. Would this be the? Would this be like in the gray, like across?
Okay, so we've got, this is across for group 1. This is the average score at repeated measure 1. This is the average score about repeated measure 2, repeated measure 3, repeated measure 4. Okay, but our question is, do scores vary across repeated assessment of factor B collapsing across group? So which in this table, which means are being compared for this second question?
Oh, would this be all of the means in the like brownish area?
Yeah. So which one? What's my first mean?
So like 137.6.
Okay. So those are my betweens, and so we captured that. What are my withins for everybody collapsing across?
Oh, okay. So like 222.50, and then all the like all those.
So which ones?
I could be. I don't know. Is it like the 222.50, 266.7?
Okay. So those are person level means across repeated measures. So where do we got? So what for collapsing across assessment of factor B? Which means are we got there? Which ones? Yeah. So it's going to be this one, this one, this one, this one. So here what we've got is collapsing across group. What we're taking is the average across for all people in the study. We're taking the average score for their repeated measure for at time 1. And then at time 2, we're taking everybody's mean and take at time 3, time 4. And so with this, what we're doing is we're ignoring group. Whereas the first one, we ignored repeated assessments. I don't care what the repeated assessment is. I'm just taking the average across here, here, and here, right? Second one, and that's our between subjects. Our within is saying across repeated assessments. If we ignore group, are we seeing differences in these means across here? Okay. And then our last question is, do repeated measure scores vary as a function of group? Okay. What are we asking here? What question is this?
Interaction.
Yeah, an interaction or moderation, same thing, right? We're looking at a between by within interaction here, and we're saying, is there variability across these, right? That's not accounted for by the main effect of group and repeated measure. Is there variability in this set of means that differs enough to count as its own thing? Okay. So this starts to become important. We're knowing like where things are coming from, where things are going. So within this, within the the A by B case, right? We've got a sum of squares total. This is just all the variability in your model, right? This is of all the scores taking total variability. This is your total piece of the pie, right? This is the whole thing. Then we got our sum of squares between subjects. What we're doing is we're taking our number of our repeated measures, W. So taking W times the sum of my subject mean minus my grand mean. right? I've got this minus the grand mean, this minus grand mean, this minus grand mean, this, right? We're just taking the mean of our subjects, we're subtracting it for the grand mean. This is giving me my between subject stuff, right? My group and my between subjects, what I'm going to do is I'm going to split sum of squares total. I'm going to split it in between, within, okay? Then I'm going to look at my sum of squares group. This is the systematic, across my between subject stuff, this is the systematic differences that I can attribute to group, right? And that's going to be the number of people in my cell times the number of repeated measures I have times some of the squared deviation scores of my group mean by minus my grand mean, right? Okay, so of the total between subject stuff that I have, what's systematic that I can attribute to whatever my grouping factor is? I got my sum of squares for my repeated measure. This is down here, this is part of my within. I'm going to take that as the number of people in my cell times the number of groups I have times the deviation of my repeated measure for my grand mean right here. Grand mean for my repeated measure and deviating each one of these from my grand mean. Okay. Excuse me, these ones from here. Okay. The systematic stuff that's going across. My sum of squares cells. This is just kind of my within subjects thing up here. This is a big computational thing. You don't have to worry about that too much, although probably will want to know that for Bakeman. And then you got your interaction term. Sum of squares for the group by repeated measure here. We get this from subtraction. If I take sum of squares cells minus sum of squares repeated measure let me check on that. I'm getting lost on, I think I got turned around on what sum of squares cells here is. Let me follow back up. I got myself turned around on the sum of squares there. Yeah.
And let me know if you just want me to come to your office hours, but like, I'm like really confused about what a lot of these symbols mean.
Sure.
So like, I don't know what W is.
Oh, up there in the little box.
But what does that mean? Like, what does
That's your repeated measure.
W is repeated measure?
Well, in this slide, this is the thing. Notation is going to be different, so you want to go through and make sure that you've got notation squared away here. So yeah, for this example, W is going to be your repeated measure within, N is going to be the number of people in each one of your cells, and then group is going to be the number of your group here.
And then is GM grand mean?
Yep.
And then G dot RM.
Yeah, that's your the grand mean of your repeated measure.
Okay.
So yeah, I tried to sort of set these up. So here, for your sum of squares cells, it's going to be your sample, the number of your sample times the mean of your grand mean of your repeated mean minus your grand mean. So that's going to be here minus this minus this minus this minus this.
Okay.
Like that. Okay. And
So NW, number of within.
yeah, so this is going to be 3 times 4. Right. So you've got 3 participants, 4 within subjects of repeated measures, and then you've got your sum of your square deviation scores here.
Oh,
Does that help?
yeah.
And this is all assuming a balanced design and sort of all that type of stuff, just to kind of simplify things.
Okay, thank
Okay.
you. What is that?
That's repeated measures times subjects within group. If you go through, Katie, and also look at, so I've got this kind of tool down. I didn't take a close look at some. Yeah, so take a look at this too in terms of breaking this down. I'll go through, get this clarified, and send out an email to help sort of track things. I'm pretty sure that past Josh set this up right because I've sort of checked this a number of times, but I'm kind of missing something in terms of where things are going. I'll get back to you, get this explained and get back to you with stuff. Does that sound good? Okay, cool. So yeah, what we're doing is we're just thinking about with this, separating things from between subjects to within subjects and then trying to figure out sort of where these different variance components come from. Oh, look at that. Deviation of all scores, the grand mean. Deviation of, oh, look at that. I thought that I had saved myself, but then I didn't. This is a computational piece that scores cells. Yeah, I'll figure it out and get it sent to you. All right. Assumptions of our mixed factors ANOVA. We've got our normality assumption highlighted or asterisked here because it's going to be our assumption of distribution of sample means as opposed to our actual observed distributions, right? So again, if we've got sampling for something that has a normal distribution in the population or something that has a reasonably large cell size, right? We would know that the distribution of sample means is going to approach normality pretty quickly here. Homogeneity of variance across groups for between subject stuff. Within subjects, again, normality, distribution of sample means. We got homogeneity of variance across intervals, okay? And then sphericity assumptions here. Examples that we're going to go through and work on. So we've got, again, sort of sticking with the same data sets that we had used previously. What we're now going to do is just work in a within subjects or a between subjects component to that. And so what we're doing is we're taking that original analysis of inpatient depression, and we're going to say, okay, instead of just looking at everybody, we're going to say, what we've got is 3 different programs. We've got someone in program 1, program 2, program 3. And so our question is do depression scores vary over the course of 6-week inpatient hospitalization? So are we seeing differences across repeated assessments collapsing across treatment groups? So if we ignore treatment groups and we just look at scores across treatment, do we see changes? Here, do overall depression scores across treatment group, right? Here we're saying, like, if we just collapse across repeated assessments, do we see differences in the scores across program? And then our interaction here, we're saying, does the pattern of depression scores vary based on treatment assignment? Okay, here's our action, here's our interaction, here's our moderation. Here's where we're saying, do we see differences in means across time change depending on whether or not we're talking about program 1, program 2, or program 3? Okay. Questions about sort of this first conceptualization or this first problem? thinking about this, which of these questions is which of these questions or these tests here is probably going to be the one that's least useful? What do you think, Basha? Yeah, you're absolutely right. It's the second one. Why is this, given the context of the problem, why is this not terribly helpful? Okay, yep. So we don't know exactly because we've got, so what we're looking at saying, we're saying collapsing across repeated measure, do we see differences in our three treatment groups? Okay. Why might not this be super interesting given kind of the way what we've set up here? What's our unit of measurement for this second question? We're saying collapsing across time points. Yeah, Josiah?
Just because we think individual differences in depression scores vary.
What's that now?
Just because we think individual depression scores, individual differences in depression scores vary.
Okay, so we're expecting individual different scores in depression to vary, certainly. But remember, for that between subjects piece, which is we're kind of reducing it down to like a one-way ANOVA type of situation, right? And so, yeah, I don't know. Third years, any idea? Sort of like, why might not this, or second years, why not this? Might not this make a ton of sense given the question that we're asking, or anybody?
Maybe because you're looking at symptoms at intake and symptoms at 6 weeks and they're kind of averaging out.
Yeah, and not just symptoms at 6 weeks at intake in 6 weeks. We're talking about symptoms collapsing across the whole treatment, right? So if we average symptoms at intake 2 weeks, 4 weeks, and 6 weeks, and we're saying across those averages, do we see differences across groups? That's kind of a weird thing to ask, right? Like we're not. So overall, if I take people's average depression score, do I see differences across groups? Well, I might, right? If I've got something that looks like, so I've got groups 1, 2, and 3, then maybe I might see something in terms of just differences across these, right? But it's not really a question that seems to make sense, right? If I take the average depression score of folks in group 1 versus the average depression score in folks in group 2 and average depression score in groups 3, I don't know, because I'm expecting everybody to kind of start in the same spot, and then maybe some people to decrease more than others. But if that's to the extent to which that's going to translate to, I've got all this other stuff kind of sort of is kind of canceling it out. And so the second one, like my model will test it, but it's not necessarily probably going to be an informative test unless I just have really, really massive differences across my groups. Okay. But here, regardless of people who are receiving treatment, do we see changes in depression over time? Hopefully that would be useful, right? If we're doing something helpful. But even collapsing across groups, I'm saying that, yeah, people who are just in inpatient treatment are getting better, right? But what starts to tell me really whether or not we're seeing effects of my treatment group, of individual treatment groups? Which of these effects? What's that, Sam? The third one, right? Does the pattern of depression scores differ across treatment assignment? If I get a pattern like this, I'm very much in interaction, right? Because there's different stuff going across these. And this is going to be more informative. And this is that interaction, what I'm going to hope to find, as opposed to just collapsing across depression scores. Do I see differences? Okay. All right. So we're going to roll into an extension of that one. And then Here, we've also got our unordered means. And again, we're going to kind of condense this down, but extend on the stuff, on the analyses that we've already run. So we're asking, what we're doing is instead of having 8 vignettes, we're just looking at the trauma focused ones. Okay. So we've got 4 vignettes. And what we've got is we're going to have a grouping profile sort of based on people's general sort of biases. We'll call them biases towards sort of endorsement of stereotypes. So they're different profiles, right? We've got one group that's negative, that this is just like a high prejudice group that says, yeah, people who've been exposed to trauma are crazy and they'll kill people if they get an opportunity and they're violent and so on and so forth. We've got a benevolent group that are like, oh no, they're nice, they're the same as everybody else. They need support and so on and so forth. And then a third group that's sort of more based on back, oh yeah, no, they're fine, but I would be hesitant to get in a relationship with someone who hadn't experienced significant trauma, or I would wonder if they're going to be okay to be parents. Like generally, I think they're fine and I don't think they're dangerous, but I just wonder about sort of interpersonal concerns and things along those lines, right? So we've gone through and we've categorized respondents into, we'll call them 3 different bias or stigma groups. And what we're going to go through and say, does willingness to befriend people vary across different types of traumatic events? What effect is that? That's our within, right? That's going to say, are we seeing collapsing across belief groups? Are we seeing differences in sort of the people's willingness to provide support for hypothetical survivors of sexual assault, combat trauma, motor vehicle accidents, and disaster? Okay. And then we're saying, does overall willingness to befriend other people differ based on belief profiles? What effect are we looking at there? That's my between. And Basha, in this case, is this between effect? Is this between subjects effect interesting and meaningful? Potentially, why? Okay.
That impacts.
Yeah, we've got a different scenario this time, right? So we're not saying like, if I'm not taking average depression scores across time when I'm measuring people, I'm just saying across these vignettes, right? In general, do I see differences in how much friendship people are willing to provide these hypothetical survivors collapsing across vignettes? Now, all of a sudden, I've got a between subject effect that actually is kind of interesting, right? Like, regardless of what vignette they're responding to, am I seeing between group differences in across these different, say, stigma profiles? Now, all of a sudden, I've got a between here. This is kind of a stupid question that I don't know that we would spend much time thinking about or analyzing. Now, all of a sudden, we've got a between subjects effect that, given the context, starts to be interesting and could have some interesting implications. And then finally, we've got, does belief profile impact the pattern of friendship across ratings of events? This is now saying, does the pattern of does our pattern of willingness to provide friendship, does this specific pattern differ depending on which belief group that we're talking about, right? And so again, this is our interaction. We're saying, does belief group moderate the types of the pattern of means that we're seeing in terms across these different profiles? Okay. Questions about this? Yes. Yeah, within effect, sort of remember, think about our, instead of 8 scenarios that we've had, we just condense it down to 4. And so this is just saying, do we see differences in pattern of means across these different vignettes? If I fail to reject the null, Emily, what would I find? What would that look like if I failed to reject? They're all the same. Doesn't matter if we're talking about combat trauma, car accident, sexual assault, disaster. People are basically saying the same thing. Collapsing across groups, people are basically saying the same thing across each one of those. So we have no within subjects effect. Yeah. Is that?
I think so.
Okay. Okay. So within this, so which one of these, so it's all part of the same analysis, but which of these effects do we have the most power to test? So of these, of your effects, which one of these effects has the most power. The within, and the within by between, okay? That's actually a pretty powerful test. The straight up between starts to become limited because, and again, it starts to become really, as Matt pointed out, it basically reduces down to a one-way ANOVA, right? So the number of people that I have in my group starts to make a difference in terms of the effect that I'm trying to figure out there. So this starts to become relevant for power analyses when you're running your stuff. You want to be very specific and be thinking very carefully about what specific effect is it that I'm hypothesizing I'm wanting to find. With these types of designs, what are we, if we're running this type of design, what are we generally wanting to test? Go for it. Be brave, Emily. The interaction. Yeah, we're almost always wanting to test the interaction, right? It's basically saying, does this pattern of means change depending on which group I'm looking at, right? And so luckily within these designs, that between by within is still a pretty powerful test. Some of it depends on actually the shape of that interaction, but in general, sort of that's generally okay, right? So just wanting to think about what am I doing? What are the questions? And this will start to become important when we get into the actual examples and sort of teasing out sort of what's actually happening with things. Okay. How's that sound? A-okay, thumbs up? All right, cool. We'll stop there. And what we'll plan for next week, take a look at your syllabus and just kind of move everything down a week, okay? In terms of assignment for problem set 2, push that back a week so you got more time for that. I'll go through, get stuff clarified in terms of this previous slide, and I apologize for blanking on that. I'll sort of make sure that you have a good understanding of that. That will help with the Bakeman article. Still keep sort of plugging away on some of these. I'll go through and present I've got some screencast stuff. If people just want to just sort of jump into this and sort of watch the examples before we come in and talk about them in class, I've got screencasts that you can go through and watch those. I mean, we'll do the same thing here, but if you want to do that, and if that helps you sort of move forward with, get a head start on the analyses, that's cool too. So I'll make those available, but we'll sort of push everything back so that we're still going through and on time with things. Sound good? Awesome. All right. Thanks, everyone.